So far, we've just worked with integer data types, %d. There are other data types that we want to learn because not everything falls inside of the integer classification. Maybe we have a letter that we want to look at. A letter is a character, so then we would have %c for character. So I've got integer %d, we've got character %d. Then we have decimal. If we have an answer that comes out in decimal, we want to be able to accommodate. In decimal, we can use double, which is also called long float, or just a regular float. Long, L for long float is just going to hold more decimals, more bigger numbers than a float would. So you can use either one, double or float. With what we do, it doesn't make a difference. I just like to use double, so I'm going to use double with my examples. If you've done programming before and you're used to float, there's no problem to continue using float. Okay, so %d is an integer. We've used it in scanf %d. Notice the scanf is the one that has the ampersand, not the printf. We can't print an address, which remember, that's what this symbol means, the address of. We can read in from the keyboard. We can scanf an integer into the address of this variable, but we don't print addresses. We will later when we come to pointers, but for now we are not. So notice there's no ampersand in the print statement. But in a print statement, when I use a placeholder, I have to have a variable to fill in to this placeholder. The contents of this variable here is going to be filled into that placeholder. We've talked about this before, but if I have, say, 3 placeholders, then I need 3 variables. Each variable in order will get filled into each placeholder in order. Okay, if we're using decimal values, we switch to double or %lf. So we're going to read in from the keyboard a decimal, and we're going to store it into the address of this variable. When I want to print that decimal, I need a variable that its contents are going to be replaced into the placeholder for printing. Okay, so %d integer, %lf double, %c is character, a single letter. Like let's say we want our programs to loop. We might ask the user, do you want to loop again? Yes or no? And have them type in Y, a single letter or a character for yes. We would read that into our scanf statement. Okay, so %d integer, %lf double or decimal, %c for a single letter, a character. And when I use a character in scan, not in printf, but when I look at using a character in scan, I have to leave a blank here. If I don't, it's not going to read in that single letter correctly. So you need to leave a blank there in order for the scanf to work. But we're still scanning, we're still reading in one letter into the address of this variable. Okay, when we look at not only adding to our integer data type, double, and character, we can also add to our libraries. Right now, the only library that we've used is the standard input-output library. We can also use the math library. The math library has so much in it that you'll want to check it out. The math library has so much in it, but for us, we might start out with using simple things like if I want to take the square root of something. So I'm going to take the square root of x, or whatever variable is inside of that parenthesis. Sqrt is the command that I want to use. If I want to raise to a power, we use POW. If I want to take an absolute value, we're going to use F abs, so absolute value. Okay, so SQRT, POW, and FABS are reserved words. They come from C's math library. Okay, let's look at POW because we use that a lot. POW, X, Y, just think of Y as the power. So if I want to calculate, say, 5 to the 7th power in C, we would say 5, 7. And that would calculate 5 to the 7th power. Okay. Some programs require operations beyond plus, minus, multiply, divide. That's why we're including the math library. We can include it in our program like we include standard input output. Here's just 3 of them. There's so many. You got to check out this link. But some common ones are like sine, cosine, tangent, square root, power. There's a lot in there. Okay, so let's look at another program, and this program we're going to need to use doubles. So we want to introduce doubles in this program here. Fish swims, fish swims at a speed v relative to the water against a current 5 miles per hour using a mathematical model of energy expenditure. It can be shown that the total energy E required to swim a distance of 10 miles is given by this function EV. Okay, so V is our input. V is the speed relative to the water. Once V gets input, we're going to get output E, which is the energy. Okay, so here's the formula for calculating EV. Okay, so what we want to do is we want to write a program to calculate energy expenditure at different speeds. Especially for our beginning programmers, first thing that we do is pseudocode for everybody, test cases, and then for everybody putting the program into C. We do pseudocode so we have that outline of things that we want to get done. Then after we have that detailed outline that's in English only, that's called our pseudocode, we make that into the C programming language, and then our test cases verify that our program works correctly. Okay, for these, I mean, the pseudocode isn't much. For this example, what we want to do is we want to think about what would I need to do if I had to get this done by hand, and that's your pseudocode. Okay, so if I had to do this by hand, I would pick a V to plug in, and this is a typo here. That should be a V. We would pick a V to plug in. Once we got a V to plug in, then that would give us our energy, and that's really not very many steps. So when we think about it in pseudocode, we're going to read in V from the user, whatever they turn in, but V is going to have to be greater than 5. Why greater than 5? It can't equal 5 because we'd have a divide by 0. Greater than 5 would make sure that energy expenditure is always positive. Okay, so we're going to read in V greater than 5. We're going to calculate and print energy, and then we're done. That's all we need for pseudocode. I didn't have to worry about, do I need the scanf, do I need the POW, do I need to loop. I don't have to worry about the syntax of the C programming language. All I have to do is write a detailed outline of what I need to do to get this done. Then I can program it, then I can put it into the C language much easier. Once I have pseudocode, then I can look at reading in my volume. That would just then relate to the scanf. Not volume. I can read in my speed. That's what V was. So we're going to read in speed. Make sure it's greater than 5. We're going to calculate and print energy. and then we're done. Okay, here's my test case. If I read in a V of 8.5, I hand calculated what this would come out to be if I read in an 8.5. 2.73 times 8.5 squared times 10 over 8.5 minus 5, we should come out with a value of 4,790.175 for our answer. And then this will just verify that our code works.